Hello students, we are in last illustration of chapter 7 alternating current in this video. 11th illustration it is. The question is, show that in free oscillations of LC circuit, the sum of energies stored in capacitor and inductor is constant in time. So before we start with the energy equations, let us recall the charge and current equation for LC oscillator circuit. We know that when charge capacitor is connected to an inductor, charge is oscillating with LC and so is the energy. So the instantaneous value of any charge can be given as Q is equal to Q0 cos omega t, where omega t is frequency of oscillation, Q0 is initial charge deposited on capacitor, and I can be given as Q0 with negative sign omega sine omega t, and of course here omega L is equal to 1 by omega c, so we can use the equation omega square is equal to 1 by root LC. Let me give it equation 1. Now we know that energy of capacitor, which is stored in form of electric field, if we call it UE, it is Q square by 2C. So I can write this as UE as Q0 square cos square omega t by 2C. Let me call it equation 2. Similarly, inductor stores its energy in form of magnetic field. So let the energy of inductor be UB, which is equal to half Li square. So half L Q0 square omega square sine square omega t. Now instead of this L, if I use this formula, it becomes 1 by omega square c, and then the equation is 1 by 2 1 by omega square c Q0 square omega square sine square omega t, and then this omega square and this omega square gets cancelled out, and then what I'm left with is UB is equal to Q0 square sine square omega t and 2C in denominator. So the total energy of the circuit, if it is U, it can be given as energy stored in form of electric field in capacitor, energy stored in form of magnetic field in inductor, and then it is Q0 square cos square omega t by 2C plus Q0 square sine square omega t by 2C. Taking constant terms out, we realize that we are left with cos square omega t plus sine square omega t, but cos theta plus sine theta, when we add their squares, gives 0, and hence the answer is Q0 square by 2C. The term indicates that there is no time involved, means this energy is not time dependent, it is constant, and hence we can say that the energy stored in LC oscillator circuit is constant. Though the individual energy of capacitor and inductor are time dependent because we have T appearing in their expression, but in the final equation total energy is time independent, it is constant with time. Thank you.